it's Cliff here. We're at about part 14 of RapidTurn. So I've just received a replacement unit, and it's early March. I got the original one back in about early November, so it's about 4 months now. What a journey this has been. So I really feel for Tormach. This has obviously really cost them in terms of time and money. It's been a real hassle for them, I can imagine, an absolute nightmare. I console myself that it would have been that much worse if this issue hadn't been discovered until later. I mean, imagine if another year had gone by and had been selling them for 2 years and had sold hundreds more, the problem will be just that much worse. So I console myself that it was a good thing I found it, even though it opened a can of worms for everybody. Now I'll get on and open it up and check it all out and hope everything's alright. I must admit there's a part of me that just doesn't want to look too closely. I couldn't bear the thought of finding something else. So I'm forcing myself to do this. Alright, well, let's measure the all-important spindle bore. So let's have a look down there, and you can see the smaller diameter is location fit is now there at the back. And remember our specifications from the Harding specs, Harding 5C specs, that the back bearing should be 1.2500, between 1.2500 and plus 0.0002, 2/10, so it should be between 1.2500 and 1.2502, should be in that range. Okay, so we have our Tessa micrometer. We're checking the calibration with some matrix slip gauge. It's rung on 1.25 inches. Checking it at the actual position, and you can see there it's very good. It's showing 31.75, which is the metric equivalent of 1.2500, 31.75, because it's a metric micrometer. And then I've carefully passed the telescopic gauge in that back bearing, and that's quite a skilled process to get it set exactly right. I won't go into that now, but and we'll just carefully measure the maximum position, and we're getting 1 point in metric 31.76. Now that's slightly out of spec. It's 31.76, and 1.2502 in metric is 31.755, so it's 0.5 hundredths too big, very slightly too big. That's about 2/10 of a thou too big, which is a little bit disappointing, but it's not a massive amount out. I notice on the certificate of inspection they give a specification for the back bearing run out now, but they don't give a diameter, which is unusual for a precision fit. If it needs to be interchangeable, you should give a diameter. But anyway, it's not there. But according to the Harding specs, it's 2/10 of a thou too big in bore. Well, just going over using a telescopic gauge. It's a pretty tricky process to set it really correctly. If you open the gauge inside the bore on the maximum angle and tighten it up a medium amount and move it very slowly off center just with one pass, you'll still have a little bit of compression on the telescopic gauge, and you'll get a measurement that's, I know this from many years of experience of making fits, that is slightly big using that method. Yes, and it's 31.765. But if you pass it through more than once, you run a very real risk that you'll compress it too much because the telescopic gauge won't necessarily find the perfect maximum center. So it takes a lot of skill to pass it through more than once and get exactly the right fit. It's not an easy thing to do. Probably the easiest thing to do is to pass it through once, get the measurement, and know that that is slightly tight, that fit. In other words, you're measuring something a little bit bigger than the actual bore. But I've passed it through several times until I get a very close location fit, and I'm getting 31.76. Using a telescopic gauge to measure a bore is very difficult, and there are much better ways of measuring a bore that with more expensive instruments that require a lot less skill. So just keep that in mind. It is a tricky thing to measure. There's a lot in metrology, and it's a really interesting subject. I've always been fascinated with it. You've got to take so many different things into account. For example, thermal expansion. I've been holding the slip gauge in my hand for a couple of minutes, and it's up to body temperature, but I haven't been holding the micrometer, which is in ambient temperature. Now remember, when I measured that, I got 31.75. Now when I measure it, I'm getting 31.754. So it's increased. That slip gauge stack has increased by 4 microns just in a few minutes of holding it. Just the thermal expansion compared with the mic. If I'd held the mic as well, it probably wouldn't be showing a difference. So that's one of the many things that have to be considered when you're doing precision measuring. While I'm on the subject of bore measuring, this equipment is used for very accurate bore measurement. It's called a die test measurement system, and it uses very accurately calibrated rings, and you set the appropriate dial indicator, taper, expanding probe inside that calibration ring, and calibrate the dial indicator to a size very close to the part you want to measure, and then you can very accurately measure within a very small amount, better than 1/10 of a thou or a micron, the exact bore diameter. Unfortunately, this set doesn't go as big as the 5C collet diameter, so I was not able to use it for this job. Of course, if you want to check your telescopic gauge bore measurement, you can turn in the lathe a plug gauge to the size that you've measured, which was 31.755, and we could turn a plug gauge to 31.754, a micron smaller, and then it should insert with a very snug fit. But I don't want to take the time to do that. I'm fairly confident that measurement of 31.755 is correct. I could measure a 5C collet, but of course these are just cheap collets and they'll be quite a bit undersized. I'm getting 31.74, which is a 1.5 hundredths of a millimeter undersized, because it's smaller than spec and the bore is bigger than spec, and therefore you would expect this to be quite loose in there. And you can see from the amount that it's rattling that it is quite loose. That feels like about that amount of clearance. Well, that's quite a good introduction to the idea of go-no-go gauges. So that's when you turn two plug gauges, for example, 1/10 of a thou undersize, so that would be just under, so it should go in, and 1/10 of a thou oversize, so it's just bigger than the bore, so it won't go in. And you mark on it go, no go. So when you're doing production machining, you check that the go goes and the no go doesn't go, and that's a quick way of, and a very safe and accurate way of checking. with the Arbor is on spec and saves this time-consuming, skillful use of, for example, a telescopic gauge. The old and the new. You might remember with the error in my original spindle bore is 0.25 of a millimeter too big, or approximately 10th thou too big. I had to put a sleeve on my arbor so that I could use it. I machined the arbor down first and then shrunk on a sleeve and machined it to a close fit in the bore that's too big. I was hoping Tormach would send me a replacement arbor, but they didn't do that, so I'll need to either make another arbor or import one, or grind that one down to the new specs, which is probably going to be the quickest thing to do. On the subject of whether my new RapidTurn is a reconditioned unit or a rebuilt unit, well, the certificate of inspection, this is number 211, shows the new design with the back bearing specified. So this is, and it's looks like this is from China. So it looks like it's come from the factory. So it's either been reconditioned or built from new in the factory. I'm leaning towards the fact that it's an old spec unit that's had a new spindle put in, because if you look closely at the RapidTurn front, you can see it's a little bit damaged on this surface here, where it's been gripped in a vise or on a press, perhaps when it was when the bearings were pressed out or in. And you can see here on the front surface the paint, the metal is bruised enough to raise the aluminium. There's a lump there, and the paint sort of also raised in that surface. So that leads me to think that this is a rebuilt unit from an old unit in the factory. Okay, well, that's worth knowing, that they've probably reconditioned one of the earlier units and replaced the spindle, because I know it's very easy to get that wrong. It's very easy to damage the spindle or the spindle bearings, or get the bearings slightly out of alignment. So what I'll do now is I've put the old one back on the machine and run them side by side and have a careful listen to the spindles running to make sure the new one's running okay, because I know my original RapidTurn runs beautifully. Let's just run it now and have a listen to the old one. On the high speed range, and we're just going to take it up in steps. So there's just the whoosh sound, there's no other sound. Again, a lovely smooth sound. No bearing tinkle. That's perfect. It's really quiet. Okay, so let's listen to the new one now. Okay, I've connected up the new RapidTurn, the one that's had the spindle replaced, and let's just run that now. I don't know if you can hear it through the camera, but there's two sounds. There's the whoosh of the motor and bearings, but there's also a high-pitched ticking noise. It's a tick 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 sound. I'm not an expert on bearings. I don't think that's a healthy sound, but I'm not really qualified to be 100% sure. It is a lot noisier than the other RapidTurn, and I think that ticking sound is bearings. But it doesn't sound extremely bad. It doesn't sound like it's about to seize up. I have noticed that it's very free to turn compared with the original RapidTurn. So I presume that's the preload on the spindle bearings is a bit less, or they've used a lower viscosity grease. It has got that ticking sound, but it's disappointing. But I don't know enough about bearings to be sure that that is a serious problem. Let's run it now with the belt off to see if it's the motor that's the problem. No, it's not that. No tickety tick ticks there, so the sound's coming out of the spindle bearings, I presume. It occurred to me overnight that perhaps the problem is that the adjustment on the spindle bearings is a little bit loose. It's definitely easier to turn than the other one. So I've just backed off the locking grub screws on the adjustment nut and just given it a little bit of a tweak there. It's still pretty loose, but I've turned that adjusting nut maybe a 20th of a turn, just snug that up slightly. You can check that the spindle signal's working if you go to the status page and look here on the encoder Z LED. Now if I rotate RapidTurn spindle, you'll see it come on in a particular position there, and in one more rotation it'll do it again. So you can see from that that the little sensor's working. I suppose they call it a Z encoder because it's used to keep the Z movement in sync with the A axis, the rotary axis. I'm not an expert on software, and so I don't really understand why it's called a Z, but it must be something to do with that, I presume. That's probably enough clips to put together for video 14. I've done some tests on it, and that seems to be a genuine certificate of inspection. I probably won't go through them all at this stage. I noticed the actual errors on the test certificate are greater than on my original one. I just happened to get a really good original one apart from the spindle bore. Now I've got one that's not quite as accurate. But you know, the errors are within the allowable errors, and I'm sure it'll be okay. There's a couple of things that are slightly out of spec. Well, the spindle bore is slightly too large by the Hardinge specifications, but you know, only slightly, only half a hundredth of a millimeter. And there's a little bit of bearing noise, which may be just an adjustment issue. Time will tell. Isn't that life though? You know, 2 steps forward, 1 step backwards. Nothing ever goes 100%. And engineering's a bit of an analogy of life, isn't it? You make decisions that are black and white. You go left or right. But you make those decisions based on information that's just shades of grey. And that's life, and that's engineering. But I think the shades of grey are acceptable, and I'm going to move on and get underway with this unit, and hopefully all will be well. Thanks for watching, guys. See you later.